multiple lens and mirror combination problems. If I have an object here that is 5 centimeters in height, 20 centimeters in front of a diverging lens with a focal length of -10 centimeters, and to the right of the diverging lens there's a converging lens with a focal length of +20 centimeters, and the distance between them is 30 centimeters. I want to know where the final image will be. The final image location, and what is its height going to be? Is it going to be inverted? Is it going to be real image? Is it going to be imaginary image? Right? So you could kind of have different cases. You can have an image that's magnified, which is bigger image, or you can have a smaller image. Inverted or upright, you can have the image inverted or upright. Virtual or real, it could be imaginary is another word for saying virtual, or it could be a real image. Real image is an image where you could actually put a screen there and you can actually see the image. Okay, so let's apply the lensmaker's equation. 1/do plus 1/di is equal to 1/f. The distance, object distance, is given as 20. The image distance we don't know. The focal length is -10. So 1/di is equal to -1/10 minus 1/20. This one goes over there. And then this becomes -20 minus 10 over 200. Right? So where is that? -30 over 200. And the 0 and the 0 cancel. So 1/di is equal to -3/20, therefore di is equal to -20/3, right? Reciprocate this, so that gives you something like -6.6 bar centimeters. So graphically, what does that mean? Well, visually speaking, the focal length of this is 10 centimeters, so that brings us somewhere about here, halfway between. Well, when we do the ray diagram of this, we see that rays that are straight bend in such a way as they are coming from the focal length right here. And then rays that are intended for the secondary focal point, there should be another focal point here. The rays that are intended for that focal point, so something like this, okay, end up being bent straight. Okay? So if you take this ray and you go back, at the intersection of those, that's where the image will be. Okay? So that's about 6 centimeters, right? 6 centimeters back this way. So the diverging lens tends to form an image that's closer to it. Okay? What is the converging lens going to do? So these rays are now going to go this way. And then there's, of course, other rays, right? They go like this. And then the converging lens tends to form an image somewhere here, okay? So how do we do that one? Well, what you do is you treat the image of the first lens as the object for the second lens. How far away is it now? What's the distance from here to here? Well, if this is 30, and then you have another 6.6 this way, so the total distance is 36.666, right? So you have 1/do plus 1/di is equal to 1/f. What's do? That's going to be 30 and then 6.66, so 30.666 with a bar. 1/di, and then this is going to be 1/20. Okay? Because this is now a converging lens, so it's +20. So 1/di is equal to 1/20 minus 1/30.666. And of course you can cross multiply, and then you get 30.666 bar minus 20/20 times 30.666. And then invert both sides. So you're usually doing that. You're cross multiplying here, and then you're inverting them. 1 over di is equal to, if you invert it, you have 20 times 30.6 bar over, if you subtract this, you have what? 30 minus 20 is 10, so 10.6 bar. So let's do this. di is going to equal 57.5 centimeters. Okay? Well, that means the final image is going to be all the way 50 centimeters. That brings us way, way to the right over here. So visually somewhere over here maybe. Okay, somewhere over here, way to the right of the board. Okay? So where is that distance measured from? It's 50 centimeters measured from here. Okay? 50 centimeters that way. From the second lens. Okay? So now, what's the magnification of the lens going to equal? Here's what we do. We now know where the image is, right? The total magnification of the lens is equal to the magnification of each image that you form along the way times each other. Magnification of the first image times the magnification of the second. If there were multiple images, you would do M1 times M2 times M3 times M4 times M5 and so on, right? So what was the magnification of the first image? Negative di over do, let me call this 1, times the magnification of the second image, negative di2 over do2. Okay? Since you only have two images, you have two negatives and they cancel. So the total magnification, what was di1? Well, di1, remember, was negative 6.666, right? Negative 6.6 bar. What was do1? Well, that was the original. That was 20, right? Notice that these are all unitless numbers. This is centimeters over centimeters, which becomes unitless. Okay? What's di2? Well, that's this one, 57.5. Okay? What's do2? That was the 30.6666, right? 30.6 bar. So basically, just take the product of all of that. Negative 6.625. It's unitless. So what does that mean? Well, the image looks about 60% as big as it does the object, and it's inverted, right? So it's basically going to be over here, 60% as big. So the negative means it's inverted. The 0.6 means it is diminished. If it was greater than 1, it would be enlarged, magnified, right? But if it's less than 1, that means it is a diminished image. So it will look something like this. What is the height of the image going to be? Well, that's going to be 0.625 times the height of the original object, which was 5 centimeters. So the height of the image, 0.625 times 5, 3.125 centimeters. 3.125 centimeters. And since the magnification is negative, we can say it's negative. Negative 3 centimeters. So if this is 5 centimeters, this one will be negative 3 centimeters. Is the image going to be real or virtual? Okay, how do we know that? One way you can do it is to sort of analyze the ray diagram and see what's happening. If this one is acting as an object for that, if the focal length of the converging lens is 20 centimeters, that means the focal length of this one is about here, right? We learn that converging lenses form real images when an object is outside of its focal length. So since this object is outside of that focal length, the rays will come from here and they will converge onto that point right here. Okay? So you will actually be able to put a screen there and form an image. What is really happening here is that this virtual image here, there was never a real image there, right? There was a virtual image. This virtual image acted as a real object for this lens, and it formed a real image. Okay? So this object forms a virtual image. The virtual image acts as a real object for this lens. And that forms a real image, inverted image over there, since the image here is outside of the focal length of the converging lens. Next we will do a 3 lens and mirror combination. Thank you very much.